Today we're going through the second part of creating linear equations in one variable. Writing equations is an extremely important part of math. Businesses, governments, schools, hospitals, and many others require the use of equations to evaluate how they grow and function. And those who can write equations to model situations are in very high demand these days. In this video, we'll take equation writing one step further and include instances of increase and decrease by percentages, as well as combinations of work and time. We're going to start off with Linda, who's purchased a pair of pants and had to pay 5% sales tax on her purchase. If Linda paid a total, including tax, of $65.31, how much did the pair of pants cost before tax? I'm going to throw in here that one of the most common mistakes that students make is not reading through the context fully. Please make sure that when you're given a paragraph where you have to create an equation and solve, that you take the time to read it through at least once. Most students skip to the very last sentence, and it really does them a disservice and makes their job much harder. So now that we've read through the whole thing, we can now just pay attention for a minute to the very last sentence. It's asking us how much the pair of pants cost before tax. And since that's what it's asking for, that's our unknown. And we're going to create our variable so that it equals what the question is asking us for. X in this case is equal to the cost of the pants before tax. So when you go shopping, you pay a certain price, let's say for a pair of pants. And then what happens if you have to pay sales tax? In this case, it says that Linda had to pay 5% on her purchase. Since she only purchased the pair of pants, she has to pay 5% or add on to her price 5% of what the pants cost. So in a situation like this, I need to change the percent into decimal form, 0.05 in this case, and multiply it to the price I was already paying. 0.05x will give me 5% of my purchase. So we have the original cost, we add on the sales tax, and the scenario is saying the total, remember total means equal, is $65.31. Now I have an equation to model the situation. To solve this equation, if you'll notice on the left-hand side of the equation, we have some like terms that need to be combined. Again, a very common mistake that students make is not paying attention to x and remembering that x is the same as 1x. If I have 1x and I add it to 0.05x, that's going to give me 1.05x, still equal to 65.31. Dividing by our coefficient, I get x is equal to 62.20. We're not quite done with this problem because remember, it's important to explain your solution when your equation comes from a situation. 62.2 means what to Linda? In this case, it means Linda's pants before tax cost $62.20. Let's move on to example 2. Gray gets paid on a weekly basis, but 12% of his earnings are taken out for taxes. If Gray's net pay each week is $655.60, how much does Gray earn each week? quick finance lesson, just in case you don't know, net pay is sometimes called take-home pay. That's the amount that you physically get a check for from your job. But there's another type of pay called gross pay. That's what you actually earn. When you take your gross pay and you subtract the taxes, the federal and state taxes, from your gross pay, that's going to equal your net pay. So again, make sure you've read through the context completely, then take a look at what the situation's asking for. It's saying, how much does Gray earn each week? Or in other words, what is Gray's gross pay? So my variable, my unknown, is Gray's gross wages. So Gray makes this money, and in this case, are we going to add or subtract the 12%? Since the taxes are taken out of his paycheck, we're going to subtract 12% of his gross pay. So 0.12x gets subtracted from x. And then it says his total net pay, or his pay each week, is $655.60. Now we solve the equation. We have some like terms to combine. 1x minus 0.12x leaves me with 0.88x, still equal to 655.6. Dividing by our coefficient, or dividing by 0.88 from both sides, we get x is equal to 745. And what does that mean to our situation? Well, that means that Gray gets paid $745 each week. Or we could say Gray's gross wages are $745 each week. There's a lot of different ways that you can explain the situation or explain your solution. Just make sure to use your own words. Last but not least, we're going to look at a very common type of math problem called the work problem. And we're going to go over a type of work problem where two people, or they could be two objects, can do the same job but at different rates. And we need to answer questions about how fast they can do the job together. Let's take a look at a scenario where Tasha can mow a particular lawn in 4 hours. Using a different kind of mower, it takes Kyle 6 hours to mow that same lawn. We want to know how long it will take them to mow the lawn if they work together. This type of problem all comes down to rate. This is a very tricky type of problem if you've never seen it done before, but hopefully we can fix that for you today. We're going to start with Tasha. If Tasha can mow the lawn in 4 hours, how long would it take her, or what rate could she do the lawn in only 1 hour? Or how much of the lawn, I should say, can she do in only 1 hour? Wouldn't she be able to do 1/4 of the job in 1 hour? Sure. And how about Kyle? If it takes Kyle 6 hours, how much of the lawn can he do in only 1 hour? He can do 1/6 of the job. These are called unit rates because they're how much can be done in only 1 unit, in this case, in only 1 hour. Well, working together, we can combine their rates. So they can get 1/4 plus 1/6 of the job done in only 1 hour. We're going to take that combined rate and we're going to set it equal to 1/t. And I know that looks a little funny. T actually stands for time. In this case, it's the number of hours it will take them to get the job done while working together. If they could get the job done in, say, 3 hours together, each hour they could get 1/3 of the job done. If they could get the job done working together in, say, 8 hours, then together in 1 hour they could get 1/8 of the job done. That's why instead of setting it equal to t, we set it equal to 1/t, because that's how much of the job they can get done in 1 hour. So now how to solve this equation. We need to combine like terms. In this case, we have two constants on the left-hand side of our equation. And to add two fractions together, we need common denominators. We could use any value or any multiple of 4 and 6 that they have in common, but in this case, most often you want the least common denominator, and 4 and 6 can both go into 12. 1/4, if I multiply numerator and denominator by 3, I get 3/12, and 1/6, I can multiply the numerator and denominator by 2 and get 2/12. So I have 3/12 plus 2/12 equals 1/t, and now I can combine my two constants on the left. 3/12 plus 2/12 leaves me with 5/12, still equal to 1/t. There's a few different ways to solve this type of equation. Cross products is a very common way to solve a proportion like this. But since we're looking for ways to simplify the process, if you need to solve for t and you have 1/t, it's fair to flip both sides of your equation over. It's fair if you remember to do it to both sides. So I can switch this to 12/5 equals t/1, and then I can simplify. t/1 simplifies to t, and 12/5 reduces to 2.4 when I do the division. So I can say t is equal to 2.4. What did t represent in our context? The time it took for Tasha and Kyle to mow the lawn working together. So to describe or explain our situation, I'm going to say that Tasha and Kyle can mow the lawn in 2.4 hours if they work together. Alright, I could go through many types of work equations, but we're going to just limit ourselves to this one for today. Remember, you can rewind the video and go through examples again, but for now, have a great day, and I'll see you next time.